A nuclear bomb has 3 pulses. If you look at North Korea has 2 satellites that go across the U.S. 4 times a day. And they've even touted about being an EMP device. At 300 miles, so you have your satellite here, and you have the East Coast and West Coast. It has at 300 miles, it can actually go from coast to coast. It will also go up into the southern part of Canada and also the northern part of Mexico. When an atomic bomb goes off, and it doesn't have to be big, it doesn't have to be big, it gives off gamma rays. It gives off the gamma rays, which hits the protons, which give off an electron. The gamma rays hitting the protons, all of this happens between 5 and 500 billionths of a second. It's very fast. That's why our device has to, under military specifications, mil standard 188.125.1, you have to be able to take that spike and shun it within 20 nanoseconds. We're way below that. The electrons come down, and how's electricity? Electricity is the flow of electrons. So the atmosphere is charged, and it starts charging the whole atmosphere. So now you have your power poles out here with your power lines coming into your house. The power lines is a large antenna. All the electrons hitting it provides a very high pulse coming into your house, normally in the thousands and hundreds of thousands of volts, not your 110, 220 like normal. And the grid itself is getting hit with millions of volts. But also, your whole area is charged because the atmosphere itself is charged. So when you have electrical lines within the house, they also get bombarded with the same electrons, causing you to have a spike internally in your house. With our device, we're taking it and looking at it and taking it to ground when it sees any kind of fluctuation above the threshold at the electrical panel. And that's why when we see any kind of a spike above the threshold that is set for, we take everything to ground and conductor to conductor, so the spike doesn't reach the person's equipment. Now, again, the wire between our unit and where the equipment is in the house is still part of an antenna, but we are still shunning it at the panel. So the impact to the piece of equipment is very negligible for the normal shielding. That's the first pulse. And like I say, that goes between 5 and 500 nanoseconds.
E1.
That's the E1. E2 follows right after that, and it comes in milliseconds, just a few thousandths of a second later. That pulse is not as high in amplitude of spike, but it is like a very strong lightning strike.
And it goes further.
And it goes further. So here is the U.S. Here we are in Kansas. The E1 will go this far. The E2 will come out like this. And then the E3 gets out past that. So the closer you are, like if the satellite did go off at 300, you're going to get hit with all 3 spikes. As you start going out towards Colorado, you're still going to get hit with the 3 spikes, but after Colorado and you get across, then you're going to get hit with 2 of them. The second E2 and the E3. One is in nanoseconds. E2 is in milliseconds. And then the E3 travels slow. And it might take 30 minutes to get to the East Coast or West Coast, but it is long and drawn out. These hit and they're finished and they're out of the way. But the E3, literally because you are charging the atmosphere all the way across the charge, it's going to come up slower, and our unit will take and clip it and drop the voltage on the house. As it starts coming back up, because you still have that slower wave going out and it's going to last longer, when it comes back up, we drop it again. It's on the threshold. We keep dropping it. That is what an EMP is. A nuclear EMP has 3 different spikes. We protect against all of those. There's some myths. If you go to our website, myempshield.com,
Okay.
look under resources. We do not use any resource that we have come up with. We use third party. The very first one talks about E1, E2, and E3. So I would recommend that you go to the website, look at it, but it also has another place for myths. Most TV producers and all, when it hits, everything dies. That's not true. There's a lot of myths there. And according to the U.S. government's EMP report that was put out, it talks about how 90% of the cars, or 95% of the cars, will be fine because they're already shielded. Your cell phone is a very shielded device, so are notebook computers. They're designed that way. EMP hits, yes, it will turn them off, but you can turn them back on. The biggest thing is the chargers that go to it, that hooks into the wall to be able to charge it, getting hit with that spike if it isn't shunted.